Transformation of equations to linear form. Today we'll be looking at transformation of equations to linear forms. We have several types of equations in physics, but basically we are going to look at exponential equations and logarithmic equations. These are the most common equations in physics, and we will see how to transform them into linear form. Let us start with exponential equation. Exponential equation has a unique feature in which we have the presence of what? Letter E in an exponential equation. For example, we have this one as A is equal to R e raised to power theta. This type of equation in which E frequently occurs are known as exponential equation. And the basic thing we do for exponential equation is introduction of what is known as ln. So now this equation 1 can be transformed as ln A is equal to ln R plus ln of e raised to power theta. But mathematically, E is the same thing as 1 over ln. So when we introduce E as 1 over ln in this equation 2, we have ln A is equal to ln R plus ln 1 over ln theta. This 1 over ln theta, ln will cancel ln. So we have ln A is equal to ln of R plus theta. This is basically one way of transforming logarithmic exponential equations. Let me bring another one. Let's see this equation 2. This equation 2 says R is equal to A e raised to power eg over k bt. This equation 2, we have the presence of E inside. So we will apply ln also to it, so that we have ln R is equal to ln A plus ln E eg over kbt. One unique feature is that we are introducing ln to all the alphabets that are on the numerator. We are not going to touch the alphabets that are powers. Any alphabet that is in the power in this equation, we will not touch it with ln, but we will touch all the alphabets that are on the same pedestal. And this is what we have done here by this operation. Therefore, we have ln R is equal to ln A plus ln. This E is the same thing as 1 over ln, and this alphabet will fall as Eg over kbt. The Eg on the numerator and the kbt on the denominator. We have ln will cancel ln, so that we have ln R is equal to ln A plus Eg over kbt. Rearranging to linear form, we know that linear equation says y is equal to mx plus c. So if we rearrange this one, we have ln R is equal to Eg over kbt plus ln A. So that our y-axis stands for what? Ln R, and our m stands for Eg over kbt, while our x-axis stands for t and c stands for ln A. This equation is being transformed to linear form. So now, let's go to logarithmic equation. An equation that has no e inside, it says to be logarithmic. Example, if we are given PV raised to power gamma is equal to k, we introduce logarithm to all the powers, to all the alphabets on the numerator. Since there is no e here, we will introduce logarithm, so that we have log p plus log v to the power of gamma is equal to log k. Applying the law of indices on log v, the gamma will drop, which will have log v is equal to log what? K. So this is being transformed. But upon looking at the table provides for p and v. If this is our table here, we have p and v parameters. So if the table is having p and v, we have to rearrange in a linear form, such that we make log p the subject of the formula. So therefore, log p is going to be equal to minus gamma log v plus log k, because I'm taking this one to the other side to leave this log p as the subject of the equation, such that it will form y is equal to mx plus c. And this, my y stands for log p, my x stands for log v, and my m stands for minus gamma, where log c stands for the intercept. With a sketch of this, it shows that here we have log p and here we have log v, and it is going to be a negative graph falling. It is plummeting, in which our slope here forms minus gamma, and this forms our intercept as log k. So this is one example also of logarithmic graph. And let me put another example so that we solve here. If we are given equation 3 as r is equal to a theta raised to power n, there is no e here, so we go straight and slot in our logarithmic, where we have log r is equal to log a plus log theta to the power of n, so that we have log r is equal to n log theta plus log a. This one has been transformed into a straight line graph, whereby our x-axis we have log r, our y-axis we have log r, and our x-axis we have log theta, and m, our slope m is n, and the intercept we have what? Log a as the intercept. So with a sketch like this, it shows here as log r, here is log theta, and this is a positive graph with our intercept here as log a, and the slope here becomes n. So basically, this is what we have today on transformation of equations to linear form.